So when we talk about this idea of integrated enterprise systems, we have to first think about where we were and then how we got here. So if you remember, and some of you may not remember, but a very long time ago, all we had were mainframe computers. We didn't have the option of the laptops and the desktops, and we essentially worked at our desk via connections to a computer in a computer room somewhere in the organization. We then, of course, evolved to personal computers, where now we have laptops and mobile devices and all types of other different technology breakthroughs that provide end user much more functionality and capability at the end user location rather than back at the server location. We are now also moving into this local area networks, and we'll talk about the difference between LANs and WANs a little later on, but we're better connected now through local area networks that we really don't need to be connected directly to a mainframe anymore. And we also have the internet, which has obviously grown and, to where it's looked at more now as a tool and an asset rather than a liability. To being able to process data, and the internet opens up this idea of cloud computing, which hasn't been there before. And so this is kind of the path that we took, going from these standalone silos to an integrated enterprise system, and we do this by being able to leverage the growth and development from mainframes through personal computers, local area networks, and then to the internet. We also used to, when we thought about how we organize our organizations, we looked at standalone silos where we have individual functional areas that really essentially stand by themselves. So we have an accounting system that stands by itself and it meets the needs of the accounting department. We have a human resource system that stands alone by itself and it meets human resource needs. And maybe perhaps we have a customer relationship management or a supply chain management system, and they stand alone by themselves and they meet their users' needs. Well, now we've gotten, and before they used to be connected by this, what we call spaghetti code, where we didn't really, they could talk to one another, but the systems weren't built to leverage one another. They talked to one another, these silos talked to one another when they had to in order to get information, but not as a routine standard operating functionality, and which now we've gotten to this integrated enterprise system with the three-tier architecture where they are all integrated, and as a function of the design of the system, they operate as one system, one fully integrated system, meeting the needs of all of the users associated with all of the functional areas within the system. And so, as we said earlier, silo architecture is organized around functional areas such as supply chain management and accounting. And so here we see these silos, and they're called silos because they look exactly like silos. And the accounting or the information systems, technology systems were designed around each one of these individually. We had this three-tier process where we had a database tier for each individual silo. So we'd have a supply chain database, a production database, human resource database, and so on. We have this application tier, which has this server on it that stores the application software, and then we have the interface to the user tier, which are the front end of the office, which are the client computers. And in many cases, we see the inefficiency associated with that, where we may have to rekey information. So we may have to key in the same information into the supply chain tier silo, or the human resource silo and the accounting silo. And so there's not a lot of efficiency there. It opens itself up to increased cost. It opens itself up to the loss of accuracy. And so we can see a lot of the disadvantages of this silo architecture. And so here we see that these silos could be connected to one another to where they do interface, but on a more limited basis using what we call spaghetti code. And that uses programming code to connect the functional silos. Data can then be transferred between silos using the spaghetti code. This eliminates some data rekeying. Notice that each silo still has its own user application and database tier, though. So we still have separate databases and we still have separate server applications. So we can see the difference here between that and an integrated enterprise system, which uses a database that is shared across the enterprise. There's basically one application tier and one user interface. The integrated enterprise system permits users to enter data once and then share the data across functional areas, such as human resources sharing payroll data with accounting. This reduces the need to key the same data into the system. And so I think you can understand when we look at this that we see the efficiency that comes along with this integrated enterprise system, the reduced threat or risk of inaccuracy. Another big advantage is that now all users are drawing the same data from the same enterprise database, so decisions are being based on the same data, not on data that's independent to each silo. So there's some commonality, some understanding and commonality related to one source of information input into decision making. And so, for example, when items are entered at the receiving dock, an employee on the dock can enter the items into the system. When an integrated system is used, the accountant can then use the same data that someone else has entered to match it in the PO matching process, which then becomes the basis for paying the invoice. So integrated systems share data. It lets others enter data for you. And so again, we see when other modules such as supply chain management enter the data, accounting and finance module is updated automatically, so there's no rekeying, and so that we don't worry about the risk of inaccuracy, we don't have the cost issues, we're able to leverage some efficiency functionality there. The same is true that when accounting and finance updates data, other modules are updated automatically. So as payroll is calculated, perhaps the HR system, which may track gross salaries and wages paid to an employee, could also be updated at the same time. So there's a lot of efficiency and enhanced functionality that goes along with these integrated systems. Obviously, these generally cost more as well and are more expensive to maintain. So we say that the enterprise system is interwoven to support the value chain activities. And so again, we've seen this picture before, this representation before, where the accounting system supports the supply chain management system, the operations and production system, and the customer relationship management system through the exchange of data electronically throughout the supply chain. An example here is Owens Corning's factory floor employee can enter shipments of roofing shingles into the system and update the accounting records at the same time. So an integrated enterprise system uses three tiers. The database tier consists of a large centralized relational database plus the relational database management system software, or RDBMS. The application server, the middle tier there, consists of specialized computer programs that store application software programs such as the accounting software. And then the user tier obviously consists of the what the users see. It's the front end that the users see that includes an interface that permits data entry and data retrieval. And that's the client computer, or the user tier. And so software for the database tier in an integrated enterprise system is the relational database management system. That's the software that manages the database. The RDBMS permits users to insert, update, retrieve, and delete data from the relational database. So for example, when accounting transactions are entered into the system, the RDBMS updates the accounting data in the relational database, storing the accounting data. Application software includes the software for each module, such as the accounting platform that's used, the client relationship management platform, or the HR platform. And so we may have multiple different application software being used by the different functional areas, but they reside in the application tier on these servers. And then we have this user interface, which includes the on-screen database forms used to enter data and the on-screen database reports used to review retrieved accounting data. And so now we'll talk a little bit about SAP, which is one of the larger premier integrated enterprise systems that are used across multiple different sized companies. And we can see that SAP Business One is an integrated system for small businesses. SAP Business All-in-One is the product that's offered as an integrated system for mid-sized business. And then SAP Business by Design is the integrated product offered for very large businesses that either want to have their database managed in the cloud, or which is another way of saying a processing center, or they may be managing this themselves on company property. But the Business by Design is the large business product offering by SAP. So SAP can be used when an enterprise wants to move beyond just accounting software and wants to integrate the accounting system into other systems within the enterprise. It was one of the first integrated enterprise systems available. SAP was once used only by the largest of enterprises, and now it offers integrated systems for small businesses and mid-sized businesses. And so here we see a comparison between Oracle e-business applications, who is a competitor of SAP Business Suite modules. And we can see they offer essentially the same suite of products. They may call them a little bit something different, but the product offerings within the integrated enterprise system are about the same. Now, there are obviously a lot of different functionalities with each of these systems. Each have their own strong points and weak points. But they are very similar in nature, as one would expect, because they're meant to address the operating needs of business or organizations varying in multiple sizes. So this is the navigational screen for SAP if we're looking at the sales order processing. And so down the left, we see the navigation, right? And on the right, we see really what amounts to a form that we use to enter data, right? And so when you look at this, based on prior discussions, you might be able to think about some of the tables that are used in order to build this sales order form. And so think about when we look at the customer, we have to enter a customer number. So that we might think would go back to a customer table, right? And think about when we're entering in the order for the customer, we might enter an item number, which again might go back to the item table, right? And so you can see that entering into this form, we might be able to enter certain fields that go back and query specific tables to perhaps auto-populate certain other fields. And this is just the SAP look to one of those forms. This is another look to a delivery receipt, right? So again, when we think about it, you can kind of figure out based on what we talked about in Chapter 5 where this form would appear in a data flow diagram. SAP refers to the sales cycle or sales module as order to cash. It is called order to cash because the cycle starts with the customer order and ends when cash is collected from the customer. Notice what is similar to the invoice form used by small business accounting software such as QuickBooks. Although SAP is more complicated than small business accounting software, after you learn the basics of accounting software, it is possible to transition to larger systems. It's also possible, once you understand how SAP works, to transition to Oracle and vice versa. So there are certain fundamental elements to these integrated enterprise systems functionality that does allow you to move between the different products once you've understood how one works. So because they're similar in design, it's just the level of functionality, and then the level of customization that may follow the business is what kind of influences the complexity and the organizational uniqueness of each system. And so in SAP, we see that it contains a customer cockpit, they call it, for tracking customer information. Notice the yellow, green, and red lights to alert the user to areas that require attention. The customer cockpit permits the viewer to track shipments and delivery status at a glance. And so we can focus on the items that are red, right, that either need information or they haven't met certain criteria to get to a green or go or good. And then we have the yellow, which are the triangles there, which tell us, hey, these are items that are cautionary, and we may need to initiate some action to get them from yellow to green. Also, SAP permits the user to view sales analytics in an interactive, dynamic fashion. And so here what we're looking at is analytics being the identification of relationships between financial and non-financial data, and it allows us to view those relationships on an ad hoc basis or as we want to see them. And so again, this is just functionality in SAP and kind of a look at that. In an on-ground class, I actually walk students through not SAP, but the system I'm more familiar with, and that's Oracle, and how it's executed at an organization that I'm familiar with, some of the screenshots associated with it. SAP refers to the purchasing cycle or module as procure to pay. The cycle begins with procurement and ends with payment to the vendor. This is a sample of the purchase order screen for SAP. Again, notice that the navigation appears on the left with purchase order selected under the purchasing module. And so when goods are received, the SAP Goods Receipt PO is used to record that, and that's the screen we see in the right-hand section of this screen capture, Goods Receipt PO. And so because SAP is an integrated system, it has the capability to detect when there are duplicate bills entered in the system. Exceptions are flagged so the user can then investigate. So this is one of the other advantages of having sort of a one-stop shop or one integrated system versus having different modules for different functional areas, is that because it is integrated, because there is one database behind the scenes, you're able to leverage all of the information in that database and perhaps build in some controls, internal controls, more efficiently than the other process of having different applications by functional area that then have to be integrated. This is just a sample of screens used to record time worked in SAP. And so the journal entry screen in SAP is very similar to the on-screen journal entry scene in accounting software. Notice the columns for account, name, debit, and credit. Also notice how debits and credits are totaled for comparison. The SAP General Ledger account displays a column for debit, credit, balance, and cumulative balance. Information at the top of the account shows the account number, company code, and business area. And so this is just simply showing if we wanted to query a general ledger account to understand what the balance was, this just simply shows us what that balance is, and it provides us the detail of the debits and credits that are in that account. And generally speaking, there would be a drill down function to where we might select one of these rows and be able to drill down into the debit or drill down into that credit to see even more levels of detail, or perhaps even the journal entry that makes up getting to that debit or credit balance. So these can become very strong software research tools too. And so we also have this idea of a digital dashboard. And this screen sample shows you an example of how the accounting data can be analyzed to create business intelligence. Notice that this digital dashboard is displayed in Excel software. And so, essentially what we use with these dashboards is to provide executive management with quick glances at the key metrics that they need to see. And so maybe they come in at the beginning of each day, and as they boot up their computer, these dashboards appear so that they can review the prior day or the prior week or the prior month's activities. Provides them with a quick way of seeing visually where we are. So are we meeting budget? Are we on target? Are we under budget? So we're off target. Where are the areas we need to pay more attention to, and where are the areas that we're good to go in, so we can kind of refocus on the problem areas, but doing it in a way that's very visual and very quick and easy, so they're not fingering through page after page after page of detailed report. And then they can, as they identify the areas they need to spend more time, they can focus that time digging through these pages and pages of information to better understand that. So again, these dashboards are an area we'll talk about later, but they're really growing in popularity, and we just see them being used more and more and more across industries. And then SAP also contains a query wizard as part of the reports module. And so you can see on the left-hand side that navigation screen that we're in the query wizard. It's the row about halfway down the page that's highlighted. And so notice in the right-hand side, the screenshot of that query wizard, notice how the user can select the database table and database field for the query. And so after the query is run, SAP displays the SQL statement, and that's what's circled in red there. And so we talked about SQL statements, and you should be able to remember this idea about what the select statement means, the to statements, and the where statements, and why those are important, and what the fields out to the right of each of those mean. So based on that, then, just kind of answer to yourself, what are the database tables and fields used by this SQL statement in the query? And so there's a lot of information now being distributed on this idea of cloud computing. And so cloud computing essentially means that we are not maintaining whether it's the data or whether it's the processing of the data, and in some cases it's the legacy system or old system data. It may be the reports. It's that we as an organization are not maintaining those. We're maintaining them out at a data center. That data center we're now referring to as the cloud. And there are certain computing services associated with the cloud, and you can see them here that it's the infrastructure, it's infrastructure as a service, or platform as a service, or software as a service. And the infrastructure as a service, this cloud service model lets you outsource the IT equipment needed to support your operations, including data storage, hardware, servers, and networks. Then the infrastructure as a service provider owns the equipment, and you are essentially renting them. The platform as a service is where the cloud provider provides the platform. That is the programming languages, the operating systems, the networks, the servers, and storage needed for you to deploy or develop application software. And then the software as a service is where the cloud provider rents you the use of the provider's software applications, such as the accounting software. So instead of running the software on your own on-site computers, you typically use a web browser or mobile application to access the cloud application. And there are, of course, multiple different issues that come up with each of these. And what companies will do is enter into a service agreement surrounding these different types of services with a cloud provider that provides for issues like response time and maintenance fees and the monthly cost of this and upgrade options and scalability concerns and just all different types of information that you would essentially have to come to grips with, whether you are outsourcing this or providing this for yourself in-house. But there are arguments for why we would do this as an organization, and then there are some risks that are associated with it. And we'll cover this in much more detail later as we talk about cloud computing, because it is a growing area of importance that as a graduate student, as an information technology specialist, or as an accounting specialist, you really need to have some level of understanding around. And finally, we look at the this idea of cloud computing as it might be executed by a retail or a financial or manufacturing organization. And there are all types of different functional areas that can be outsourced in the cloud, which again is this growing trend. And these cloud computing providers include Amazon Web Services, Oracle Public Cloud, and Google Cloud Services. And these are three of the larger providers. There are, of course, numerous other smaller providers that provide different levels of service depending on the size of your company and how much you want to pay for it. And so that concludes Chapter 6. Please go back and read this chapter. It's an interesting chapter. It's meant to give you a lot of insight into the integrated computers and to cloud computing. And so please go back and read this and then proceed on to the practical exercises associated with this chapter. And thanks very much.